Today we're going to learn how to make reflections of figures. You should be on page 26 in your notes packet. A reflection is a transformation that flips each point of a figure across a line of reflection. A reflection creates congruent figures, same shape and same size, which means that they are also similar. When we reflect across the x-axis, our points change so that x and y become x, so x will not change, but y becomes negative y. Now, this does not actually mean negative y. This actually means the opposite of y. So if y was 3, it would become negative 3. If y had been negative 8, it would become positive 8. So it would become whatever the opposite of the y value was. When we reflect across the y-axis, this time x becomes its opposite, so we have the opposite of x, and y stays the same. Sometimes we reflect across a line called y equals x. This is a line that is a diagonal line, so if we have a coordinate plane, this is a line where everywhere on the line, y and x are the same. So if x is 1, then y is also 1. So it would be located here. If x was 2, y would also be 2, so you'd have a point here. If x was negative 1, then y would also be negative 1. So you would have a line that goes like this. If I have a figure over here and it needs to be reflected across this line, then y and x both stay the same. So if it was negative, it stays negative. If it was positive, it stays positive. The difference is that they change places. So the y value will flip to the x place, and the x value will flip to the y place. Let's look at example 1. This figure shows triangle ABC. We are going to graph the image of the triangle after a reflection across the x-axis. So remember that this is our x-axis and this is our y-axis. Well, if we want to flip this across the x-axis, then I know that my triangle is going to flip over here. So think about this. Since this is in quadrant 1, remember that our quadrants move counterclockwise. So this is quadrant 2, quadrant 3, and quadrant 4. So if we're flipping this way, then that means that this is going to be located in quadrant 4. Now, the way that we do this on a coordinate plane is pretty easy. Everybody put your point or your pencil on point A. To get from A to the x-axis, I noticed that I would need to move down. Well, I need to know how far down I would move. So I'm going to count from A to the x-axis. It's down 1, 2, 3. So to reflect it, I'm going to move down 3 from the x-axis. So I'm going to go down 1, 2, 3 more. And this is where A prime will be located. Now I'm going to do the same thing with B. So everybody put your pencil on point B. To get to the x-axis, I would move down 1, 2, 3, 4, 5, 6, which means that to reflect it, I need to move down 6 more. So down 1, 2, 3, 4, 5, 6. So now I have found B prime. For C, to get to my x-axis, I would move down 1, 2, 3. So for C prime, I continue to move down 1, 2, 3, and here is C prime. So when I connect these points, my triangle ends up looking like this. So I have a congruent figure, but you notice that the triangle has been flipped. Example 2 shows quadrilateral FGHJ, so this is specifically a trapezoid. we are going to graph the image of this trapezoid after a reflection across the x-axis. So remember, this is x, this is y. I want you to reflect this figure. For F, if I start here, I would have moved down 1, 2, 3, 4, 5. So I would continue to move down 1, 2, 3, 4, 5. And this would be F prime. For G, I would have moved down 1, 2, 3, 4, 5. So I would continue 1, 2, 3, 4, 5. And here would be G prime. For H, I would have moved down 1, 2, 3. So I would have moved down 3 more. And this would have been H prime. For J, I would have also moved down 1, 2, 3. So 1, 2, 3 more. And here's J prime. And then all I have to do is connect these points. And now you see that you have a figure that has been flipped. Example 3 shows triangle XYZ. We are going to graph the image after a reflection across the y-axis. So remember, this is our x-axis and this is our y-axis. So this time we're taking it and reflecting it across y. So if I reflect it across y, I can see that I'm going to end up over here in quadrant 1. Well, let's start with x. For x, I need to move it to the y-axis. So I'm going to count 1, 2, 3, 4, 5, and that takes me to the y-axis. So I'm going to continue 1, 2, 3, 4, 5, and this is going to be x prime. For y, I see that I need to move right, so I'm going to move right 1, 2, 3. So I'm going to continue 1, 2, 3 more, and here is y prime. For z, I'm going to move 1, 2 right, so I'm going to have to move 2 more right, and that gives me z prime. And now all I have to do is connect these points, and I can make my triangle that has been flipped. For example 4, we have quadrilateral MNPQ, and we are going to graph it after a reflection across the y-axis. So you see we'll be over here in quadrant 3. So everybody graph this. For point M, I noticed that I would have needed to move left 1, so I move left 1 more, and here's point M prime. For N, I would have had to move left 1, 2, 3, 4, so I've got to move 1, 2, 3, 4 again, and here is N prime. For P, I would need to move left 1, 2, 3, 4, 5, 6, so I would need to move left again 1, 2, 3, 4, 5, 6 for P prime. For Q, I would move 1, 2 left, so I would move 2 left again, and here is Q prime. And then all I have to do is connect these points. And you see that my trapezoid has been reflected or flipped across the y-axis.